Hello, Podcaster here, and we are back for part 2 of the Railcraft routing tutorial. And in this video, we are going to take a look at operators. And the operators are these three keywords here, and, or, and not. And these let you combine conditions to create more advanced logic. So by default, when you enter keywords into the routing table, they are combined with an OR operator, which you cannot see, but it's at the boot of each page. So if you enter two destination strings, for example, if either one is true, the switch will engage. And the same is true for any other condition. Now we can use the AND operator to put two conditions that both need to be true for the switch to engage. So as an example, here we have a small refueling depot, and it has an item loader and a fluid loader, and we have a switch here which we are going to give a routing table that says needs refuel equals true. So this will make sure that any train that passes by here with a locomotive that is low on fuel will be routed into the refueling depot, and this item loader will refill the locomotive with coal, and this fluid loader will refill it with water. So this refueling depot will use the stock of charcoal to supply trains with fuel. However, this is going to run out eventually. So we're going to have a fuel train that is going to carry charcoal with it and go around and refill our refueling stations, like this one. So it is going to go in here. And we have an item unloader, which will accept the coal from the cargo carts and put it into this chest. And as you can tell, we have a comparator coming off the chest that is measuring the contents, the amount of stacks in this chest. And we have a redstone line coming to this switch motor here. And as you can see, as there is enough coal in the chest at the moment, this redstone line is powering this block here. If we remove a couple of stacks from this chest, the signal will no longer reach the switch. And in the switch, we are going to put a routing table that has an AND operator followed by the redstone condition set to false, and the destination equals fuel train. So the destination equals fuel train means that only this train that has this destination string will be considered. So no other trains will ever come in here. And the redstone equals false condition means that if this redstone line is powering the switch, this train will pass right by, because it means there is enough charcoal in this chest to not require a refill at the moment. If the signal is disabled, however, the switch is going to route the train into here. So first, we are going to start this train, and we're going to use a firestone to speed it up. There we go. And then we're going to put this in here, of course. Now the first time, the fuel train is going to pass by the intersection. Now we're going to remove a couple of stacks from the chest, and the switch is no longer being powered by redstone. So now the redstone equals false is true. So now the train is going to be routed in here. Now I'm going to grab some cobblestone and fill these to make sure that it doesn't stand there too long. And we can see now that the signal is now strong enough to power the switch again. So the next time around, the train will pass by the refueling station again. So over here we also have a home base where we are producing charcoal. We're going to imagine that at least. Let's stop you for now. And here we have a routing table where we have two destination strings. So we have the main base destination, which we would use to route most trains here. Then we also have the fuel train destination, which means that this one is included because we want this to be routed in here to refill its coal supply. So we have two destination strings just right in the routing table like this, and that means that if either of these are true, the train will be routed into the main base. So we're going to add that there and then turn this back on, and it's going to be sent in here, and it's going to have its coal supply refilled. Now we can shut that down, and we're going to move on to the next setup. So in this scenario here, we have a single location represented by these two stations, and then this location we have two separate sub-destinations that we want to route trains to. So both of these have the same name. This location is called Cooltown for no particular reason. And in our passenger station here, we are going to want to route in passenger trains headed for Cooltowns. And passenger trains are identified by the locomotive color. So passenger trains are going to be red and white. Then over here, we have cargo trains, which are black and yellow. So in this routing table, we're going to use the AND condition and say that if the destination is Cooltown and the color is red and white, which means it's a passenger train, we're going to want it to go in here. And if the destination is Cooltown, but the color is black and yellow, we'll want it to go in here. So we are going to put the cargo train on the cargo carts and the passenger train on the regular mine carts. And then we are going to set the destination to Cooltown on both of these. And then we'll set them off. And we are going to see that the passenger train gets routed in here. And the goods train gets routed into the goods station. So that way we can separate the trains based on their color. Now let's get rid of these so we don't have things moving in the background. Now over here we have a similar setup. We have the passenger station in Cooltown, and we have a larger goods terminal where we have three separate goods receiving spots, and we have three separate types of goods trains that we're going to want to receive at a specific terminal. So in here we have the black and yellow locomotive from the previous setup. So here we route black and yellow. So we're going to put that in there. here we have the black and red locomotive, and we're going to put color equals black, red in here. And finally, we have the black and blue locomotive, which is the only remaining one, so we don't need a switch here. Out here, however, we're going to want all of these colors going into here. But we want only these specific locomotives, and not just any secondary or primary color. We're not assuming that all cargo trains have a black primary color and any secondary color. We want these three specific color combinations. So here we have a routing table that uses a combination of and or operators to achieve this goal. Now, this can be a little confusing to see what's going on here, so I'm going to refer to this application that I have written called the Railcraft Routing Table Editor. And as you can see, I have the same contents here that I have here. And if I validate this, first we can see that there are no errors because it successfully parsed. And I can show what it looks like if there is an error, like this. As you can see, it didn't recognize this condition before what's before the equal sign, so it displayed that there was an error. Let's fix that. And as it's successfully parsed, it adds the OR at the bottom, as is here, but invisible, you could say. And it also parses it into a tree and color codes the different levels for us. So here we can see that we have our AND operator, and it has two children. The destination string, which always needs to be cooltown, and then the OR. The OR has a child that is a color condition, our black and yellow. Then the second child of that is another OR, which has the remaining two colors. So what's going to happen is that the AND needs two true outputs from these two. This is going to output true when the destination of the locomotive is cooltown, of course. This is going to output true if either of these are true. So if the color is black and yellow, this is going to output true to the OR, which is going to output true to the AND. If the color is not black and yellow, it's going to refer to this, and this needs either of these to be true. So if the color is black and red or black and blue, this is going to output true to this OR, which is going to output true to this OR, which is going to output true to the AND. So this means that if either of these colors are present, the switch is going to engage if the destination is also cooltown. So if we go back to the game, we'll put this routing table in here. Then we are going to set up our trains like this. Turn them the right way. And then finally, we're going to set the destination in each to cooltown, like so. And then we're going to start them, set them to the right speed. Now all of them is going to be routed in here, and then they're going to be routed into their correct depot once they're all inside of cooltown. So this switch will only send these specific color combinations into the depot and only if their destination is Cooltown. So you could use this, for example, to have a coal or a train carrying a specific resource and have them all unload at specific locations. Now, finally, we're going to have a look at the not condition. So the not condition, or not operator, I mean, is pretty simple. It takes one child, unlike and or, which take two, and it simply inverts the result. So here we have a destination equals home. But we have the main line here, but the switched position points towards the default route. So if we want something to go into our home here, the switch is not supposed to engage. So when the home train comes here, we don't want to switch. So that's why we have the not dest equals home. Because this means that the default path is this way. Because when the destination is not home, it's going to switch. And when the destination is home, it's not going to switch. So we turn this on and have it go the right way. The home train is not going to trigger the switch. I need to put the routing table in for that to apply, of course. So if we try again, do that. Now the home train, who looks like it's going backwards, is not going to trigger the switch, while the away train is, because the destination was not home. And you can use this, for example, with the owner condition to trigger the switch on anyone except you for a similar result as this, and a bunch of other things. But that's enough for this video, I think. Now you should know how the operators work, and if you are writing a complicated routing table with a lot of conditions, I would recommend downloading the routing table editor and use it to make sure that it works the way you expect it to. So, with that, I will see you in the next video.